If we look at B, B is the same scenario, only now we're working with a trig function. So I'm going to write down B, and then we'll go through the whole process again. If my pen will work. We have position is the sine of t over 2, and we're on the closed interval from 0 to 4 pi. So my velocity curve, which tells me how I'm moving, is the derivative of this one, which will be the cosine of the inside unchanged times the derivative of the inside. And the acceleration will move through that constant, hit the cosine, which is a negative sine of the inside unchanged, times the derivative of the inside. So I'll have a 1/2 times this 1/2 gives me a 1/4. We're interested in when this equals 0 on the interval from 0 to 4 pi. So cosines equal 0 when the inside of that cosine graph is at the x coordinate of 0 on the unit circle. So x coordinates on the unit circle that are 0 happen at pi over 2, at 3 pi over 2, at 5 pi over 2, etc., etc. So we're here. So if I want to solve for t, I would multiply by 2. So that would give me t is a pi, or a 3 pi, or a 5 pi, on and on and on. Well, I only get to use the ones that are in the interval from 0 to 4 pi. So I'll use the pi and the 3 pi. If I want the acceleration, this is going to happen when the inside of the sine is, now remember sine is the y coordinate, so that would occur at 0 or at pi or 2 pi and around and around. So the inside would be 0 or pi or 2 pi, on and on and on. If I want to find out what t will be now, I will multiply by 2 and I will get t is 0 or 2 pi or 4 pi, etc., etc. Again, we're on the closed interval from 0 to 4 pi, so we're just going to use these three. So now we're going to put these values on sign charts for the acceleration and the velocity so that we can summarize what's going on with the particle itself. So on the velocity curve and the acceleration curve, we're going to put our domain, which is 0 to 4 pi. Then I'm going to look and see I've got a 0, a pi, a 2 pi, a 3 pi, and a 4 pi. So it looks like I'm dealing with sections that are 1 pi long. So on the acceleration curve, I have a 0 at 0, and again at 2 pi, and again at 4 pi. On the velocity curve, I have a 0 at pi, and a 0 at 3 pi. So I, on the velocity curve, need to be looking to see what's happening in between each of these sections. So between 0 and pi, say at pi over 2, I can plug that in and get the cosine of a pi over 4, which has a positive value. In between pi and 3 pi, so I'm looking between here and going all the way around again, we're going, or excuse me, I could pick, say, 2 pi. So a value of 2 pi, the cosine of a 2 pi is a or 2 pi over 2 gives me the cosine of a regular pi, which is a negative x value, negative x coordinate on that unit circle. Between 3 pi and 4 pi, I could maybe do 3.5 pi, which is 7 halves pi, so 1/2, 2 halves, 3, 4, 5, 6, 7 halves. Looks like my cosine is going to be, oops, I forgot to divide by 2, dang it. So I'll take 7 halves pi divided by 2 is 7/4 pi. So here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and it looks like the x coordinate is a positive value. So based on velocity alone, I can say that my particle is moving to the right, then it stops, then it moves to the left, and then it stops, and then it moves to the right. So I'm going to have a maximum position at pi. I could find out what it was by plugging pi into the original function, or I could find the minimum position, which occurs at 3 pi, by taking the 3 pi and plugging it into the original position function. So next we can look at what's going on with the acceleration. Acceleration, I only have to pick two numbers to test, so let's test pi. If I plug pi in, I need the sine of pi over 2, which is positive, but then I'm multiplying by a negative 1/4. So I'm going to be pushing left until 2 pi. After 2 pi, say at 3 pi, I plug a 3 pi in. That's the sine of 3/2 pi, which puts me down here, and sine is the y coordinate, which is negative, times the negative gives me a positive. So looking here, I can see that I'm pushing to the left. I'm not pushing at all, which means my velocity would be constant at that point, and then I'm pushing to the right. I can talk about my velocity being minimized here at 2 pi, and I could find the minimum velocity by plugging 2 pi into the velocity curve. I can also talk about when I'm speeding up and slowing down. I will slow down when the sign of the velocity and the sign of the acceleration are fighting each other, when they are opposites. So here I'm moving right and pushing left, so I will slow down from 0 to pi. Here I'm moving left and pushing left, so that means I'm going to speed up from pi to 2 pi. Here again they're fighting each other, so I will slow down from 2 pi to 3 pi, and then I am speeding up again because I'm moving right and pushing right. And I think that's probably anything I would ask. Last one, part C. Part C is another polynomial version. So we have s of t, or my position, is 4t cubed minus t squared minus 2t plus 10. And my velocity, I don't know if I'm going to be able to do this. My velocity is the derivative of that. And my acceleration is the derivative of that one. I'm again interested when these equal 0. So this will equal 0 when t is 1/12. And here, this we can hopefully factor. Let's see. Oh, I guess I can pull out a 2, so that'd give me a 6t squared minus a t minus a 1, which is a 2 times a 3t and a t. See, I want a minus 1. Oops, 3t and a 2t. So let's put the negative with the 3 and the positive with the 1. So I got a negative 3t plus a 2t gives me a negative t. So I can see that this equals 0 when t is 1/2 or negative 1/3. Okay, I'm on the closed interval from 0 to 7. So that means I'm only going to be working with the half and the 1/12. So on my sign charts now, I have a sign chart for the velocity curve, and I got a sign chart for the acceleration curve. For the velocity curve, on both actually, I will put my domain, which is 0 to 7, and I will put my critical value of a half on the velocity curve. This is not going to be drawn to scale, and the acceleration curve is going to be at a 1/12. Now I need to do my sign chart. So prior to a half, say at a 1/4, if I plug a 1/4 in here, this will be positive, this will be positive, and this will be negative, so the whole thing's negative. If I plug in something bigger, say 3, that's positive, 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 so I'm going to get positives all along here. If I look at acceleration smaller than a 1/12, say a 24th, plug in a 24th, I'll get a 1 minus a 2, which is negative. And after that, say at 1, I'll have positives. So we can see from the velocity curve how the particle is moving. We will start out moving left, then we'll stop, then we'll move to the right. And because v was changing from negative to positive, my minimum position will occur at a half. I can find out what the minimum position is by taking that half and plugging it into the position function. If I do that, I get out a 9.25. With the acceleration, I can talk about pushing left. My velocity will be constant because there's no push, and then pushing right. I can also talk about when I'm speeding up or slowing down. Here I'm moving left and I'm pushing left. So from 0 to 1/12, I will be speeding up. Here between 1/12 and a half, I'm moving left and pushing right, so I will be slowing down here. After a half, I'm pushing to the right and moving to the right, so all through here that particle will be speeding up.